Hello everyone and welcome to this episode. Hello every Hello everyone and welcome to this lesson. Today we are going to learn something more about binary algorithm search, binary algorithm as you know, as you call. Whenever how it's working and why we need it. It's working only in the sorted arrays or list. So whenever you've got something that is sorted, binary search will just take that task faster than normal linear search. So whenever with that sorted array, you should choose binary search. But how binary search works? Quite easy. Because imagine you've got like some kind of sorted list and from number 1 to number 10. Whenever you are trying to search for a number in a linear way, you have to go, is it 1? No. Is it 2? No. Is it 3, 4, 5, 6, 7, 8, and 9? Yes, because the target value was 9. So you need like 9 to 10 attempts because for example you start from 0. But whenever we are having the binary search algorithm, we just getting like, okay, is it 5? No, it's a higher value. So okay, then we've got only from 5 to 10, and then we strike for example to 8. Is it 8? No, it's higher number, and we've got only like 10. From 8 to 10 we strike to the middle. Is it 9? Yes, it's 9. So we've got like only 3 steps. That's the thing, that we only have like 3 steps, 6 steps less, or 7, it depends how long the array is in real life. But what we've got like 1 million elements, the things are quite important for our performance, and that's why I will show you how you can use that algorithm search. So first of all, going back. So first of all, go to your IDE, in my case is PyCharm, and I will show you inside Python how that algorithms work. First, we need random to create the data, the large sorted dataset, and to create that we need like sorted, and here we are going to have random that sample and range. Range will be from 1 to 1 million, 1 to 3, and we need like 900,000 elements here from that numbers. Of course, we need also the example target. So each time we'll just get the new target. So data random that rand int from 0 to data, sorry, len of data, because we are inside Python, minus 1. And that's our target value, our sorted data set. And okay, first of all, we'll go with the very crucial and the very easy part. So in our search, whenever we are going one by one, and I will just create attempts. So we'll just check how many attempts it needs to get to that element. And here for I item in enumerate, and data we pass as enumerate, attempts plus equals 1. So we're adding if item, so the thing is equal to the target, Then we return the I, and also we need to return attempts because we need to know how many attempts we needed. And we return -1 and attempts whenever we don't find anything. Okay, and the next thing is binary search. Binary search. Also, we need target, not target, or target value here. And we are going to create that function. Here, we also need attempts, but not only that. We need low value and also high. High will be the length of our data, so our data set, and -1. While, and here I will just show you the magic and explain you after all, because whenever we'll have everything coded, it will be easier for you to understand how we implement it inside the programming languages. And first of all, we need to check if data from the mid value, and to have that mid value, we need to have mid low plus high divided by 2. Also, we'll just add attempts because we need to have them as before, as we've got here. And we need to check if data from mid, from that index, is equal to target. And if it's it, then we return it, and we return also attempts, and that's all. We don't need anything more. But whenever data that from mid, index mid, is smaller than target, here we need to go to low, so the starting point of our data set, and assign a new value mid plus 1, because we are knowing that the first half is not what we are looking for, because the value that we've just got is smaller from the target, so we have to get rid of that first part. Whenever is the another thing that data from the index mid that we've got is bigger than the target, we need to just get rid of high, so we get rid of the second half with the bigger numbers. So that's why we assign the mid -1. And whenever nothing will work because we'll not be able to find it, we'll return -1 and attempts. And that's all. Okay, so that's how binary search we implement inside the programming thing. So there we need only two things. Linear index equals linear search, and here we pass data and target. The same thing we do with binary. So binary index equals binary search, and here we pass data and target as well. And to print the results, we will just get print index in binary, and we pass the binary index. Also print index in linear. Also here we will pass linear index right there. And to know which target value we are searching for, target value is the target. And okay, we've got everything that we need to work with our algorithm. And as you can see, the index of that value that we are targeting for is the 800,000, 43,000, 41, and we need 20 attempts only. Whenever you compare it to the attempts that we are needed to search it in linear way, it's the very big difference in the performance. Just believe me, whenever we are going to have larger data set, that difference will grow, and that difference can grow enormously. But remember, that's the very important part of our dataset. Why? Because we need to have it sorted, and that's the crucial part of that algorithm. So I hope you understand it. I hope you enjoyed that lessons, and see you at the next lesson, when and where we are going to dive deeper inside algorithms and more of them. So see you then.